All right, here we go, talking about stars and galaxies. Stars and galaxies. Let's find out exactly where you are. Where are you? Well, of course, we know we're on Earth. The Earth circles the sun. When the sun is one of billions of stars in the universe. And to measure that distance between stars, we use this distance of measurement that is referred to as a light year. One light year is the distance that light travels literally in 365.25 days. 1 year. So when thinking about a light year, let's find out how fast that is. If something goes at the speed of light, light moves at 300,000 kilometers per second. That is equivalent to 186,000 miles per second. That is fast, exceptionally fast. It would reach the sun, oh goodness, in about 7 or 8 minutes. That's speed of light. Whenever light passes from the sun to Earth, it takes about 7 or 8 minutes for it to get to us. So let's ask ourselves this question. How far would light actually travel in a year at 186,000 miles per second? So let's set up our Jack Eady Dirt Triangle. Now when we do this, I'm actually not going to do it here on this PowerPoint, but you can set up the equation. We've got our rate, 186,000 miles per second. And how many seconds are in a year? Well, we take 60 seconds times 60 minutes times 24 hours times 365.25 days. Then multiply that by 186,000 miles per second. And that is going to give you almost 5.9 trillion miles traveled in a single year. That is amazing. Now, the nearest star to our sun is still 4.3 light years away. That means it's almost 25 trillion miles away. That's just unheard of. Now, when we're talking about stars, the first kind of star we're going to talk about is a binary star. A binary star are stars that are found in pairs. Two stars that appear as one. Sometimes you can have one in front of the other, one behind the other, one very, very close to the other. These stars usually revolve around each other. You know, I think in some of my classes we talked about that little drum in Karate Kid 2, whenever the people were cheering on Ralph Macchio whenever he was fighting that other young man for the honor of his girlfriend. You know, how those little balls attached to the string and the drum kept moving in opposite directions. Well, imagine if they moved constantly in the same direction. I'll show a picture of that in just a second. Sometimes we'll get a dim star that passes in front of a bright star. It will actually block the bright rays of the brighter star. We call this an eclipsing binary, or an eclipsing binary star. Here we see it right here, binary star situation. We have two. They're swirling around one another. You can see the tail of dust and gases swirling out to the sides of both of these. This is a great example of what a binary star would look like. We have this other eclipsing binary star. It is referred to as algol. Algol dims every 69 hours. So that means that this particular star right here is moving in this direction, clockwise, around the brighter star, one time every 69 hours. That is fast, especially whenever you think about the size of these stars right here are literally probably 10, 20, maybe 100 times larger than our sun. They are moving fast. We have a special situation where we have 3 stars that form what we call a single star. This is a tri-star situation, and it's called Alpha Centauri. This is the closest star to our sun. Alpha Centauri is actually a triple star system. 3 stars close together that appear as one. Now, this brings us to a nova. A nova is a star that is getting suddenly brighter all of a sudden. I know that sounds like I said the same word twice. I guess I did. But whenever a star becomes intensely bright over a short period of time, something is about to take place. This usually occurs in a binary star system. Gases from one star pulled into the other. This kind of reminds me of that algol that we saw a little bit earlier. We saw the tail of that one star, the gases that were coming out of it, swallowed up by the other. And sometimes this causes a nuclear explosion. And that's where we're going to stop. When I pick up with the next video, we'll start with clusters. Y'all have a good night.